Okay, so what you do is you move the constant over, take or pull out the a term, which is this, the first one. Then you take half of the middle term and you square it. Half of the middle term and then square it. And then 2 times 1 is what goes in this blank. Then you factor this whole thing, which is just taking half of the middle term and putting it here. Remember to keep the 2 in front. Then move the 3 back over. And your final answer is y equals 2, parenthesis x plus 1 squared minus 3. If I were to graph this, where would my vertex be? It'd be where?
Move right. No, down 3.
Down 3.
Left 1.
Left 1.
With the thing of 2 over 1.
Good. Yep. See, y'all remember. If x equals 0, what does y equal? What is that ordered pair? What's the y-intercept?
Wait, what did you ask? I'm never good at this.
Negative 1.
Oh.
We should have a point. We should have a point at 0, negative 1. And if x equals negative 2,
It'd be
negative 1.
Yeah, I kind of forgot how to move those. I know.
Oh.
So graphing, you go left 1 because you take the opposite sign, and then down 3. And then a slope of 2. So then it says, notice the symmetry. So they're both at the same y value. It's like you could cut this in half. We're going to call that the axis of symmetry, which is just the vertical line where the vertex is. So that's our axis of symmetry right here.
Do we name the line like, which would be the vertex? X equals negative.
So if I were to make what is the equation of that dashed line? Like, what is that vertical line? What's the equation of that?
Oh, x equals 1.
Good. And it's just the x value of my vertex, because my vertex is negative 1, negative 3. So my axis of symmetry is just that x value.
It's always the x value?
Mm-hmm. Until we get to sideways parabolas, but we haven't done that yet. We won't do that until second semester.
Oh gosh, the fact that we're doing that this year.
It shows how advanced you are. So standard form, and this is kind of what we skipped over last unit, but we're coming back to. Standard form is when you see something that looks like this, A, B, and C. To solve it, we would use the quadratic formula using A, B, and C. But if we're just wanting to graph it, we don't have to change it into vertex form to graph. You can graph just from looking at the equation that looks like this. And the axis of symmetry is x equals negative b over 2a. Does that look familiar? My vertex is just the ordered pair, negative b over 2a, and then whatever your y value is when you plug that in. So you have to plug in for y. And then my y-intercept is always my c, my last number.
So that, would the C and the plug-in for Y be different?
Yes. So let's try this example. This is the same one as the first time we did it. So we're just going to compare and see if we get the same thing. Let me scroll down a little bit. Okay, so we have 2, 4, and negative 1. Those are our A, B, and C. axis of symmetry would be x equals negative b over 2a. So that would be negative 4 over 2 times 2, which is negative 4 over 4, which reduces to what?
-1.
Is that the same as what we got at the top? So x equals negative 1. They are supposed to be, because they're the same equation. So if you look at the very top,
Oh, yeah.
what we started with before we completed the square is the same equation. So my axis of symmetry is at negative 1, so I'm just going to put a little dashed line at negative 1. My vertex is going to be an ordered pair, so it's always x comma y, where I know my x is negative 1, but to find my y, I just plug in negative 1 for x. So I'm plugging it in here and here. So 2 negative 1 squared plus 4 negative 1 minus 1. So it becomes 2 minus 4 minus 1. Which is what? Negative 3. Good. So I have an ordered pair at negative 1, negative 3.
Wait, you did 1 squared. Okay, never mind.
The y-intercept is my c, it's negative 1. So 0, negative 1. And then another point, what that means is it's the one that is the mirrored reflection from the axis of symmetry, which would be negative 3, or negative 2, negative 1. So it reflects the axis of symmetry. And then from there, connect the dots. Okay, so what do we get for axis of symmetry? It would be negative 6 over 2 times 1. So negative 6 over 2 is just negative 3.
Wait, I thought it was
negative
negative
2.
negative 3. So we make it positive 6.
Oh, negative b. Negative b. You're right. So positive 3. It's Monday morning, guys. Negative b, which becomes positive 6 over 2. So positive 3. Then my vertex, I'm going to plug in 3 into the equation. So 3 squared is 9 minus 18 plus 3, which would be negative 6. Is that right? So I'm going to plot a point at 3, negative 6. Y-intercept is just my C. I'm going to write it as an ordered pair, 0, 3. So make sure that you don't just put 3. When it asks for y-intercept, that's an ordered pair, so 0, 3. What if there were nothing there? So what if this didn't exist?
0, 0.
It would just be 0, 0. And I don't know if we have any examples like that, so maybe just make yourself a little note in case it shows up. But if you didn't have a C value, it would just be 0, 0. So then I'm going to put a point at 0, 3. And then the other point, it's going to reflect. So I am 1, 2, 3 away. I'm going to go 1, 2, 3 to the right. And what would that ordered pair be? 6, 3. Then I will connect the dots. And be done.
I can't see. Wait, how did you get the vertex?
Okay, so vertex is when you plug in -2 into the x values. So I have my work right here. Because -2 squared is 4. And I plugged in -2 here.
Oh, I was talking about.
The first one?
Yeah.
You plug in 3 into the x values. So 2 times 9, 18, minus 12 times 3, which is minus 36 plus 16.
That cat.
She's not.
That cat.
What do you mean she's not?
Is it a girl?
Okay, any other questions about this?
Not a student.
All right.